I think we're going to start just because if we wait too long, we won't make it through class. Does anyone remember what a simple machine is? Okay, we'll see if Alex knows. Alex raised his hand. Alex, what's a simple machine?
Simple machines are in cylinder plates.
Oh, inclined planes?
Yeah, inside
Yeah.
plane.
Yeah, that's an example of a simple machine, an inclined plane, which is also a ramp. But simple machines help us do work. What we're going to learn today is what is a simple machine? What do ramps, pulleys, levers have in common? How can distance affect the force needed? Is there usually only one force that acts on an object? And what type of simple machine is a seesaw? So let's read about simple machines so you guys know what simple machines are. So let's have Daisy. Can you read the first two sentences?
Simple machines change the strength or direction of a force. A seesaw changes the direction of force.
Thank you. Zook,
When
one person
moves down, the other person moves. A pulley also changes the direction of the force.
and then let's have Banana read the last sentence.
You can pull down on a rope to raise a flag up a pole at school.
Okay, Sophia, can you read the next sentence? Just one sentence. Can you read the next sentence?
Some simple machine change the thread of the fox you need to do something.
Okay, Puppy, can you read the next sentence for me?
A screwdriver is a simple machine called a wheel and
Ray, are you there? Can you read the three sentences?
the handle is a wheel and the metal shank is an axle.
Mm-hmm.
The metal shank would be hard to turn without the handle.
Okay, very good. And then our last sentence. Kim, can you read it? Kim.
It takes less force to turn using the handle.
Okay, Misha, what did you do with your hammer? What did you do with the hammer?
Take the hammer to crush the door.
To crush. Oh, okay. Yeah, guys, a hammer is a simple machine. An axe to cut down a tree is a simple machine. A screwdriver is a simple machine. Let's have Jack.
Simple machines also to do something with less force.
Very good. Yeah, guys, think about if you tried to unscrew a screw with just your hands. Imagine if you tried to unscrew a screw with just your fingers. It would be very hard. The screwdriver allows you to do it with less force. Yeah, so we are looking at a simple machine. Helps us get upstairs. Can you say ramp, Rosie?
Ramp.
Yes, it's a ramp. Okay. So guys, it's time to play with our ramp. Make sure you guys stay muted. Okay, we can pick up a blueberry, peanut, almond, or piece of corn. What would you guys like to carry up our ramp? A blueberry. Cherry, how many ants do you want to try to pick up the blueberry? You can choose 1 through 6. Okay, I'm gonna call on Funny.
I like 3 ants.
3. Okay, so we have 3 ants pushing the blueberry. Do you guys think the ants will make it up our ramp? Do you think the ants will make it up our ramp? Blue Moon, do you think the ants will make it up the ramp pushing a blueberry?
Yes.
I'm going to push play. Let's see if 3 ants can make it up the ramp. Uh-oh, the ants are stuck. It's too hard for them to get up the ramp. Moon?
We need more ants.
More ants. Okay, we're going to add more force. We have 6 ants now. Let's test it out. Oh, they can make it up. So you guys added more ants, which is more force. You used a stronger force, and the ants made it up. Let's say I only use 3 ants. How can I make it go up? Pasta.
You can make the ramp longer.
Okay, guys, let's see if our 3 ants will make it up our longer stick. Oh, now it only takes 3 ants. Before, if it's shorter, the 3 ants can't make it up. Okay, let's try even longer. 30 centimeters. How
Can
many
you make
ants? So now we have a longer ramp. Let's see if 1 ant can make it up.
Okay.
No. So we have 2 ants. Okay, 2 ants is making it up the ramp. So now that our ramp is longer, it takes less force. Okay, but if we give them something bigger, okay, Sarah, how many ants would you like to try to lift up our almond?
3 ants.
Okay, 3 ants were not strong enough. Let me try 4 ants, 5 ants. Oh, 5 ants are strong enough. But if we make the lamp longer, let's see if we can do it with 4. There we go. It took 1 less ant. So guys, the longer you make the ramp, the less force or less ants that you need. The shorter it is, the more ants you need. Let's see if 6 ants can make it up the very short ramp. Not even 6 ants can push it up the short ramp. So if you want to make the simple machine better, you have to make it longer. Let's go back to our PowerPoint. Now we have something else we want to learn about. We have pulleys. This is another simple machine. Ben 10, can you read the sentences for us?
Pulley change the direction of the force. The girl pulled the rope toward them. The pulley changed the direction of that force to pull the basket upward.
This simple machine changes the direction. And let's read about our ramp. Rose.
A ramp is a simple machine. This ramp reduces the force needed to move from one level up to another.
This guy might not be able to pick up these boxes. He's using a ramp to help him out. Okay, let's look at pulleys before we continue. Okay, I looked at this one, so we're going to use this one. Okay, guys, so now we have a pulley. Now, it changes the direction of a force. Let me choose something pretty light. The armchair is the lightest thing we have. How many people? Let's just do 3 people for now. These 3 people are pulling down. Which direction is the chair going to go? Sino.
Up.
It goes up. It's like the opposite. It changes the direction. You pull down and the object goes up. Oh, they're not strong enough. Let's add some more people. There we go. It took 5 people. 5 people to pick up the chair. Now there's something we can do. If you add more pulleys, so now we have 2 pulleys, it only takes 3 people. And if I add 3 pulleys, it only takes 1 person. 1 person's able to pick up the chair. Whoa, pulleys are really useful. I'm going to show the force on each rope. This N stands for force, okay? It's a way we measure force. That's basically all I want you to know. So 1 person's able to pick up with 200 force, but our chair is 900. Is he going to be able to pick it up?
Yes.
No. So if we add 2 people, now it's 400. 800, we're counting by 200s. So now we know it's only going to take 1 more because now we have 1,000. And 1,000 is more than 900. But if we use the safe, this is even bigger. Now 5 people can't do it. 6 people can't do it. But if we add a pulley, when we add 1 person, it adds 200 and 200. It doubles the force. So now we can pick up the safe. So now we have 6 pulleys, 200. So it's only going to take 2 people. So pulleys can help us pick up things. They also change direction of the force. So pulleys are really useful. Only 4 people to pick up the piano if we use 6 pulleys. Okay, guys. The last one is a lever. Let's read about the lever. Okay, Scark.
This girl is using a simple machine called
a lever. To reduce the force needed to pry open the paint can.
So a lever looks like this. Yeah, so a seesaw is a lever. A lot easier to pick up your friend if you're on the seesaw.
Squeaks and I are exploring. We're looking for insects. We know that some insects make their homes under rocks, so we're trying to turn over a couple of these rocks to see what we can find. But they're really big and heavy, and we can't get either of them turned over. There has to be something we can do. Great idea, Squeaks. A few weeks ago, we used a tool called a ramp to help us do work. A ramp, which looks a lot like a slide, is one kind of simple machine. Like all machines, a simple machine is just something that makes work easier. That ramp sure helped us move those books into the house. And there's another simple machine that we can use to help us turn over those rocks. This one is called a lever. A lever basically looks like this. A long bar that's balanced on something underneath. And that something is called a fulcrum. By pushing down on one end of the lever, the fulcrum makes the other end go up. Just like a seesaw at the playground. It's just a long bar that's balanced on a fulcrum. Levers make work easier by helping us lift things that would be too heavy to lift on our own. If Squeaks hops on the low end of the seesaw and I push down on the high end, the lever moves on the fulcrum and I can lift Squeaks up. It's a lot easier for me to lift Squeaks this way than if I tried to just pick him up. Our simple machine made my job easier. So let's use a lever to see if it can help us lift up these rocks. All right, we'll put one end of the lever under the edge of this first rock. Next, we'll use this smaller rock as our fulcrum and put it under the middle of the lever. Now we can push on the high end of the lever and the rock goes up. Look, we did it! But it was still kind of hard. I wonder if there's something we can do to make the job even easier. Let's try something a little different for the second rock. This time, we'll put the fulcrum closer to the rock we want to lift. Let's set up our lever, give the high end a good push down, and bingo! That was a lot easier. For levers like this one, the closer the fulcrum is to the thing you want to lift, the easier it is to lift it. And that's what makes a lever a kind of simple machine. Even though it's super simple, a lever helps us do work. Levers are everywhere, and they sometimes don't look much like a seesaw, or even like the lever we use to lift our rocks. For example, did you know that when you use a wheelbarrow to carry something, you're using a kind of lever? It's true. The wheel of the wheelbarrow acts as the fulcrum, and instead of pushing down on the handles, you pull them up to lift what's inside. We use levers to open bottles too, and to dig in our gardens, and even to eat our food. We'll be back soon with more simple machines, but in the meantime, Squeaks and I have some insects to find. Thanks for joining us on SciShow Kids. Do you have a question about machines? Or this time, we'll put the fulcrum.
So the one thing I want you guys to take away is almost every simple machine has to do with distance. When you push this down, you have to move it this far down. So this distance, let's say it's 40 centimeters. Because the rock is in the middle, also have to increase this height by 40 centimeters. These are equal right now. But if you move it closer, now our one arrow is bigger. This has to travel a further distance to the ground. And now this one only has to travel up a little bit. Now, this allows you to apply your force over a larger distance, which makes the rock easier to lift. That's all that's happening. You're trying to increase the distance. If you could have your lever go up here, it would be even easier. Okay, guys, let's go back to our PowerPoint. So let's do our quizzes. You guys have 1 more minute to get in. Okay, first question. What would happen to a truck if several people began to push it? So you guys got it correct. The truck speed would increase. Okay, full question of you. What is force? Ray is still ahead. Pasta and Alex are also doing really. Oh, good job, guys. Okay, how does a simple machine make it easier to do work? Uses many parts to increase a force on an object. Decreases the force of gravity. Decreases the speed of an object. decreases the need or the force needed to move an object. Pasta's now in first. Yeah, so guys, it decreases the force needed. It decreases the force. It does not decrease the force of gravity. The only thing that can decrease the force of gravity is if you go to space. You'd have to go to space or the moon. Gravity always stays the same. Which requires the greatest amount of force to move? A bed, a person, a bicycle, or a train? Okay, Pasta got it. Good job, guys. It's a train. Okay, guys, we're only going to do one more question for today. A inclined plane makes it easier to move an object by changing. This is a ramp. This is a ramp. What does it do? Does it change its direction? Does it change the weight? Does it change the distance? Or change a weak force to a strong force? So you got it. This is a hard one. Okay. So Pasta got first, Scart, you got second, and Moon, you got third. Congratulations. Good job, guys. Your homework is going to be the quiz from the book. Bye-bye, guys.
Bye.